When creating projects for the TI safety microcontrollers, or well, Hercules devices, it's a good idea to start with the standalone tool called HalCoGen. This tool is a nice graphical user's utility, a GUI, to configure the peripherals of the device, and actually you can add in a very nice way, we're gonna see it a little bit later, the peripherals that you need for your system. However, being a standalone tool, this tool actually generates code, but it's not. It needs to have a specific procedure to be linked to a typical Code Composer Studio project, and here we are going to show how to do this. You start by creating a new CCS project, and obviously selecting the device. That's the device that I have running, and I'm gonna just give a meaningful name. I'm gonna create the UART project, and I need actually to create an absolutely empty project with no source code. And incidentally, I'm just going to add my JTAG debugger that I used here. Once you create the project, it's basically very empty. There's no source files. But an important step to be able to be integrated with HalCoGen is to simply go and check on the resource and copy the physical location on your system, the project's physical location. Once you copy, you can also go back to the HalCoGen and create your new project. To create a new project, I'm going to select the exact same device that I did before. I'm going to give it a meaningful name as well. It doesn't need to be the same name as in the Code Composer Studio project, but the other important thing here is that I need to pass the location, the same location as my previous project and the project that I created on Code Composer. And also important, just disable this option, so actually the source files generated by this code will actually be placed in my project directory. And I'm selecting the TI compiler in this case. So now the project is getting created and it's being added a lot of files. Now inside the tool, I need to configure the SCI project, or the serial project, and I can actually go simply to the help topics and show the examples. They actually go to the SCI UART, and in the help it actually shows you nicely step-by-step procedure on how to create a project and configure everything. And basically I'm gonna go and select from step 2 and onwards. I'm gonna just move this out of the way, and I have to enable SCI1 driver, and then by following the same procedure I'm going to go to SCI1 and just double check graphically if everything is correct in the data format. Okay, so I have my baud rate, everything default is actually good to go. Just for the sake of safety, I'm going to save my project, and now I'm going to actually generate the code for the project. This is actually code being generated by the tool. This code will magically show up on my project. There's a lot of source files here, and there's an include directory here. I need one more thing that is actually important. From the tool itself, from the HalCoGen itself, I need to copy one of the files that is my main source file. This main source file, it actually contains the code, that part of the code that initializes the peripherals and etc. I'll simply copy the file and paste it on my project directory. This file here is also partially replicated as this file here. This HL or HalCoGen sysmain is actually contains an empty main file. This one contains a main file that is actually already populated with whatever I want to configure. So what I can do is simply exclude the empty main file. It becomes blank here, and I can simply proceed to build my project. Oh, I forgot one important thing that I can cancel here. This is very important. Basically, the project, you see that you cannot find source file. Basically, what I need to do, and I forgot, is to simply include the auto-generated include directory. To do this, I need to simply add it to my project options. So basically, what I can do is simply add it. Oops, I forgot an important thing, which is a $sign. That is basically how you do it. Hey, there's a typo again. You need to get the syntax right. So in this case, I'm gonna add a project located directory located inside the project directory itself. So basically now I have a code building successfully. Once it's finished building, now I can proceed to simply debug it normally as I would do in any Code Composer session. And we have the code loaded now, and I can simply proceed to run it. At this point, I'm going to simply open a small terminal. It's actually, yeah, COM145 9600. The settings are correct, and I'll simply run my code. And that's that. Here's the code running successfully. That's it. I hope you like it.